Tonight I am going to try to answer a question that sounds like it should have a simple answer. A number. A fact you could write on a card. And instead, it is one of the strangest and most beautiful questions a human being can ask. And by the end of this journey, you will understand exactly why it has no comfortable answer, and why that lack of an answer is the most wonderful thing about it. How big is the universe, really? Not how big is the galaxy, not how far is the nearest star, not the distances we can walk out in the mind step by step, but the whole thing, everything, all of it, the total. How big is it? And here is the first surprise, the one that reframes the entire night, because the honest reply from every astronomer alive is not a number. It is a careful, quiet admission that the question splits, the moment you ask it seriously, into two completely different questions with two completely different answers. And one of those answers is astonishing, and the other one may be the deepest open mystery in all of science. There is the universe we can see, and there is the universe, and they are not the same size, and the gap between them is the subject of tonight. We are going to go slowly to the edge of the visible, to the farthest thing that light has ever shown us. A boundary 46 billion light years away in every direction. A wall of the oldest light that exists. And we are going to stand at that wall and ask the question every child asks, and every physicist takes seriously: what is on the other side? And the answer is going to open beneath us like a floor giving way. Because the edge is not an edge, and the wall is not a wall, and what lies beyond it is either so vast it makes everything we can see a rounding error, or it is, quite possibly, without end forever, infinite, in every direction. And we will look honestly at both possibilities and at how we could ever hope to know. This is a journey to the boundary of everything and past it, and I promise you that at least once tonight, the size of things will stop fitting inside your head, and that feeling, that specific vertigo of the mind reaching and closing on nothing, is not a failure. It is the closest any of us ever comes to actually touching the scale of the universe, and it is the whole reason to take the trip. Before we begin, 3 small things. If you are new here, subscribe, because this channel makes slow, calm, carefully researched journeys through the cosmos, made for the end of the day, made to be listened to with your eyes closed while your mind wanders somewhere vast. Press like if this is the kind of night you were hoping for, because it genuinely helps these journeys reach the other quiet minds out there in the dark. And in the comments, tell me where in the world you are drifting off from tonight and what time it is where you are, because I read every single one. And there is something gently astonishing about knowing this same journey to the edge of everything is beginning right now, in a bedroom in Lagos, a night shift in Toronto, a rooftop in Manila, a kitchen somewhere at 3 a.m. Wherever you are, stay with me to the end, because the final answer, the one about whether the universe ends at all, is the strangest and most peaceful thing I know, and I have saved it for last. Now settle in, let your shoulders drop, and let us drift into it slowly, starting not at the edge, but here, close, with a question much smaller and much sneakier. A question that seems easy and turns out to be the key that unlocks everything. When you look up at the night sky, how far away is the farthest thing you can see? And the answer, the true answer, is the first door we walk through tonight, and it leads somewhere you do not expect. Here is the sneaky thing about looking at the sky, the thing almost nobody has ever told plainly. And once you understand it, the whole night sky changes from a picture into a machine. When you look at anything at all, you are not seeing it as it is. You are seeing the light that left it, and light, fast as it is not infinitely fast. It takes time to travel. And so you are always seeing the past. This is true in your own room, where the far wall reaches you a few billionths of a second old. Too small to notice, and it becomes the deepest fact in astronomy the moment the distances grow. The moon you see is a second and a third old. The sun is 8 minutes old, and if it vanished, you would enjoy 8 more minutes of sunshine before the sky went dark. And it only grows from there. The light of the North Star left it centuries ago so that you are seeing a star as it was when your great-great-great-grandparents were not yet born. And some of the stars scattered across your sky tonight are showing you light that began its journey before the pyramids. Which means, and hold this gently, that to look out into space is always, without exception, to look back into time, and a telescope is not a window, It is a time machine, the only one we will ever build, and it can only ever point backward. Now find the farthest thing your naked eye can reach, because it makes the point unforgettable. On a truly dark night, in the constellation Andromeda, there is a faint smudge, dim, easy to miss, like a thumbprint of fog on the glass of the sky. And that smudge is an entire galaxy, a spiral of 1 trillion stars, the great neighbor of our own Milky Way, and it lies 2.5 million light years away, which means the light landing in your eye tonight left that galaxy 2.5 million years ago, before our species existed, when the most advanced humans on Earth were early upright creatures, learning to knock stones together. And that light has been crossing the empty dark for the entire lifetime of humanity, arriving tonight, in your eye, to end its journey against the back of a mind that can understand what it is. You, with nothing but the eyes you were born with, can see 2.5 million years into the past. And that is the nearest large galaxy. That is the close one. So already the question, how big is the universe, has grown teeth. Because if the nearest neighbor is 2.5 million years of looking away, then to see farther is to see deeper into the past. And the deepest we can possibly see, the farthest light that could ever reach us, must be light that has been traveling for almost the entire age of the universe itself. Light that left its source near the very beginning of time. And that light does reach us, and we have found it and photographed it, and it defines the edge of everything we can see, and it is where tonight is going. But to understand what that edge really is, and why it is so much stranger than a simple faraway wall, we have to understand the one fact that bends this entire story. The fact that makes the visible universe bigger than it has any right to be. The fact that the universe is not sitting still. It is growing. Space itself is stretching right now as you breathe, and that single truth is about to make the edge of the universe do something your intuition will fight and lose. For almost all of human history, everyone assumed the universe was static, fixed, eternal. The stars hung in their places, and the cosmos simply was unchanging. And this seemed so obvious it was barely worth stating. And it was wrong. And the person who proved it wrong did so less than 100 years ago, within the lifetime of people's grandparents, which is worth pausing on, that our species has known the true nature of the universe for only about one long human lifetime. In the 1920s, the astronomer Edwin Hubble, using what was then the largest telescope in the world, was measuring the light of distant galaxies, and he noticed something strange in that light. The color of it was shifted. Light from almost every galaxy he looked at was stretched toward the red end of the spectrum. Its waves pulled longer, and there was a clean pattern to it. The farther away the galaxy, the more its light was stretched, and the more its light was stretched, the faster it was moving away from us. And Hubble realized, and the realization reshaped everything, that the galaxies are not sitting still. They are rushing apart. Every distant galaxy is flying away from us, and the farther one is, the faster it flees. And at first that sounds as though we must be at the center of some great explosion, with everything blasting outward from us. But the truth is subtler and far stranger, and it is the key to the whole night. So let us build it carefully with the image astronomers always reach for, because it works. Imagine a loaf of raisin bread dough, studded with raisins, rising in a warm oven. The dough swells, and as it swells, every raisin drifts away from every other raisin. And if you were a tiny observer sitting on any one raisin, you would see all the other raisins receding from you, the near ones drifting slowly, the far ones racing away faster because there is more swelling dough between you and them. And here is the crucial part. No raisin is at the center. Every raisin sees exactly the same thing. Everyone drifting away from everyone, and because it is not the raisins that are moving, it is the dough between them that is growing. Now take away the bowl, take away the oven, take away the edges, and let the dough be everything there is, and the raisins be galaxies, and you have the universe. Space itself, the dough, the very fabric between the galaxies, is expanding, swelling, growing in every direction at once, carrying the galaxies along with it like raisins in rising bread. And this is not the galaxies moving through space. It is space itself getting bigger, new distance appearing everywhere between everything, all the time. And we are not at the center because there is no center. Every galaxy sees every other galaxy fleeing, and an astronomer on any raisin in the whole loaf would see precisely what we see, and would just as reasonably think themselves the still point of a fleeing cosmos and be just as wrong. The universe is expanding. Not into anything, not from anywhere, just expanding everywhere, intrinsically more space appearing between the galaxies with every passing second. And this one fact, once you truly hold it, does something remarkable to the question of the edge. Because if space has been growing this whole time, then the distant galaxies whose ancient light is only now reaching us have not been politely waiting where they were when they sent it. They have been carried away all along by the swelling of the dough, farther and farther, even as their light crawled toward us. And this means the edge of the visible universe is not where those first galaxies were, and not where their light left them, but somewhere much, much farther. And calculating where it actually is gives one of the most astonishing numbers in all of science. And we are ready now to go and find it. We have been throwing enormous numbers around all night, billions and trillions, and I need to stop and repair those words, because they are broken in almost everyone, and the repair is one of the most useful things you will take from tonight. The human mind treats million, billion, and trillion as three sizes of the same idea, like small, medium, and large. 3 cups of big. And this single quiet failure of intuition is behind more misunderstanding of the universe than any other. So let us fix it, using time, because time is the one huge quantity a person can actually feel. 1,000,000 seconds. How long do you suppose that is? It is about 11.5 days. Count one number every second, without stopping, day and night, and you reach 1,000,000 in a week and a half. A vacation. Now, 1,000,000,000 seconds, the next size up, the sibling. Not 11 days, 31.5 years. Begin counting at the moment you are born, one number every second, never sleeping, never pausing, for your entire life. And you would say the word billion sometime in your early 30s, with gray already starting at your temples. The step from 1,000,000 to 1,000,000,000 is the step from a week and a half to half a lifetime. And those are not neighbors. They are barely the same kind of thing. In 1,000,000,000,000 seconds, one more step up the same staircase. 32,000 years. Begin the count today and you finish it around the year 34,000, further into the future than the last ice age is into the past. 11 days, 31 years, 32,000 years, million, billion, trillion. Each step is 1,000 times the one before, and now hold that staircase and hear tonight's numbers again with their true weight. When I said the universe is 13.8 billion years old, you can now feel that it is not merely a large round number. It is 13.8 of those 31-year lifetimes of counting, stacked one after another, just to reach the seconds, and then each of those seconds is a year of actual cosmic time. When I said 2 trillion galaxies, you now know that simply counting them, one galaxy per second, without pause would take you 60,000 years. Twice the span since cave paintings. And that is just to count the galaxies, not the stars inside them. And when I said a septillion stars, a number with 24 zeros, you now at least know the true size of your own inability to feel it, which is the only honest relationship any human being has ever had with that number. And there is no shame in it, because the number is not built to the scale of minds. It is built to the scale of the universe. And the gap between those two scales is the very thing we've been standing inside all night. And here is a gentler way to hold all of it, the way astronomers actually do. A small trick that turns the vertigo back into something you can rest in. Do not try to feel the numbers, because no one can. Instead, count the jumps. From your own size up to the whole observable universe is about how many times you would multiply by 10, and the answer is around 40 steps. 40 10-fold jumps from a human being to the entire visible cosmos, and downward from your size to the smallest meaningful scale is about another 25 steps, so that everything that exists from the smallest thing to the largest visible thing lives on a staircase of roughly 65 steps. And 65 is a number you can hold. A number the size of a human life in years, and the whole universe, top to bottom, fits on a staircase you could climb in your imagination in a single quiet minute. And that, not the septillions, is the true friendly shape of cosmic scale. 65 gentle steps of 10, from you to everything. Let us build the number carefully, because there is a puzzle inside it that trips almost everyone. And solving the puzzle is the moment the true scale of the visible universe finally lands. The universe is 13.8 billion years old. Light travels 1 light year per year. So the obvious guess, the reasonable guess, and the guess almost everyone makes, is that we can see 13.8 billion light years in every direction, a sphere about 27 billion light years across, and that guess is wrong. And the reason it is wrong is the expansion we just met. Think about the oldest light reaching us. Light that left its source over 13 billion years ago and has been traveling toward us ever since. When that light began its journey, its source was relatively close to where our region of space would be, because the universe was younger and smaller. But during all the billions of years the light was in flight, space itself kept stretching, and the source was carried away, farther and farther, the whole time. So that today, at this moment, the galaxy that emitted that ancient light is no longer 13 billion light years away. It has been swept outward by the expansion to a distance of over 46 billion light years, and that, the current, stretched out a present-day distance to the farthest things whose light has reached us, is the true radius of the observable universe, 46.5 billion light years in every direction, which makes the observable universe a sphere about 93 billion light years across. 93 billion light years, containing everything we can possibly see, every star, every galaxy, every photograph ever taken by every telescope in history, the complete visible cosmos, 93 billion light years from side to side, even though the universe has existed for only 13.8 billion years, because the space in between never stopped growing. And I want to be sure the word observable is carrying its full weight here, because it is the most important word in the entire night, and everything after this hinges on it. The observable universe is not the universe. It is the part of the universe we can see, the part whose light has had time to reach us. And it is a sphere centered precisely, exactly on you, on your eyes, right now. Because light reaches you from all directions equally, you sit at the exact center of your own observable universe. A bubble of visibility, 46 billion light years in radius, with you at the heart of it. And this is not vanity or illusion. It is simple geometry, and it has a staggering consequence that we will return to, which is that everyone, everywhere, every possible observer on every possible world in the whole cosmos sits at the center of their own observable bubble, sees their own sphere of visibility, and no two bubbles are quite the same. But hold that for later. For now, stand inside our bubble and feel its size, 93 billion light years, and know that it is filled, absolutely filled with structure, because the next thing tonight has to show you is what that bubble actually contains. And the number of worlds inside it is where the mind first begins, gently, to come apart. In 1995, the astronomers running the Hubble Space Telescope made a decision that many of their colleagues thought was reckless, even wasteful. They pointed the most valuable telescope in existence at nothing. They chose a tiny patch of sky near the handle of the Big Dipper, a speck of pure blackness about the size of a grain of sand held at arm's length, a spot deliberately chosen because it appeared completely empty. No stars, no known galaxies, nothing. And they left the telescope staring at that empty speck for 10 straight days, gathering the faintest light. And critics grumbled that it would come back black. 10 days of the world's finest instrument wasted on a picture of nothing. When the image was developed, that tiny patch of nothing contained 3,000 galaxies. Not stars, galaxies. 3,000 of them, each one an island of hundreds of billions of stars, layered back through space and time, crowded into a fleck of sky so small you could blot it out with a grain of sand at arm's length. A fleck chosen precisely because it looked empty. And that changed everything, because it meant the emptiness was an illusion, that every dark scrap of sky, everywhere, in every direction, is packed with galaxies too faint and far to see. And once you know that, you can do the arithmetic that redefined our universe. If a sand grain of sky holds 3,000 galaxies, then the whole sky, the entire dome above and below the Earth, holds a number that does not fit in the mind. The current best estimates place the total number of galaxies in the observable universe at somewhere around 2 trillion. 2 trillion galaxies, each one containing, on average, 100 billion stars, and each of those stars we now know, very likely wrapped in planets of its own. Run that multiplication gently, and the number of stars inside our visible bubble comes out to something like a number with 23 or 24 zeros after it, a septillion stars, and there is a comparison for that number that has become famous because it happens to be true, and it deserves to be said slowly. Take every grain of sand on planet Earth, every beach, every desert, the Sahara and the Gobi and the Arabian sands, every grain on every ocean floor, all of it counted. The stars in the observable universe outnumber them. Not barely. For every single grain of sand on the entire Earth, there are something like 10,000 stars out there in the dark, each one a sun, most of them with worlds. Pick up one pinch of sand on a beach, a few hundred grains between your fingers, and you are holding the counting token for a few million suns. And I have to be honest with you here, in the way this channel tries always to be, because the sand comparison is beautiful, and it does not actually work. Not really, because the human mind cannot hold a septillion any more than it can hold the sand. The comparison just moves the incomprehension from the sky to the beach in hopes you do not notice. There is no way to truly grasp this number. What you can do, what I invite you to do, is hold two pictures side by side, the deep field, that grain of empty sky hiding 3,000 galaxies, and the beach, and let the vertigo come. Because that vertigo, that reaching and finding no bottom, is the most honest experience of scale a human being can have. And it is only the contents of the bubble. We have not yet reached the edge. And the edge, when we reach it, is stranger than the fullness, because the bubble does not simply stop. It ends in a wall of light, the oldest light there is, and that wall is the next place we are going. So we come to the edge of the visible, and I want to take it slowly because it is one of the most extraordinary things our species has ever found. And it is genuinely a wall, though not the kind you are picturing. As we look farther out into space, we look farther back in time. We have established this, and so, if we look far enough, we should be able to see almost all the way back to the beginning, to the young universe, the infant cosmos, and we can. We do. Our best telescopes routinely photograph galaxies as they were more than 13 billion years ago, small and blue and forming, the toddlers of the cosmos. But there is a limit, a point beyond which we cannot see, no matter how good our telescopes become, ever. And it is not a limit of technology. It is a wall built into the history of the universe itself. Go back far enough to the first few 100,000 years after the beginning, and the universe was a very different place, unimaginably hot, unimaginably dense, so hot that atoms could not hold together, so hot that everything was a glowing plasma, a fog of bare particles and wild light. And crucially, that fog was opaque. Light could not travel through it. Every ray of light, the instant it set out, was scattered by the dense particles, bounced, absorbed, redirected, the way light cannot pass cleanly through fog or through the interior of the sun. And so the early universe, for its first 380,000 years, was glowing but blind, luminous but impenetrable, a wall of fog with no clear light in it at all. And then something happened gently, everywhere, at once. The universe expanding, cooled, and at a certain moment it cooled just enough, dropped below a critical temperature, and the bare particles could finally catch and hold each other, forming the first stable atoms. And as they did, the fog cleared all at once, across the whole universe, in a cosmic instant, and suddenly light could fly free, unscattered, in straight lines for the first time. And it did. And it has been flying ever since for 13.8 billion years, and it is still arriving. That light, the light released at the moment the fog cleared, the first light that could ever travel freely, is still reaching us right now, tonight, from all directions of the sky, stretched by all those billions of years of expansion, from a fierce glow into a faint whisper of microwaves. And we can detect it, and we have mapped it, and it forms a wall around us in every direction. the wall of the oldest light in existence, the moment the universe became transparent, and it is called the cosmic microwave background. And it is, in the most literal sense, a baby photograph of the universe, an image of the cosmos as it was 380,000 years old, the earliest thing that can ever be seen. Because before it, there is only the fog of forever unviewable, a wall no telescope can pass. And here is the detail I love most, the one that makes it real. This ancient light, this whisper from the dawn of everything, is not confined to observatories. It is all around you. A tiny fraction of the static, the snow on an old untuned television set, the faint hiss between stations on an old radio. Was this light, the afterglow of the beginning, arriving 13.8 billion years late, into living rooms unnoticed, mistaken for noise? You have very likely seen the edge of the observable universe, the wall of first light, flickering as gray static on a screen, and never known that a portion of that snow was the oldest light there is, the boundary of everything visible, the closest thing the cosmos has to an edge. And now we are standing at that wall, 46 billion light years out. The whole bubble behind us, 2 trillion galaxies at our back, and the oldest light in the universe glowing faintly ahead. And there is only one question left to ask, the question this entire journey was built for, and it is the question that has no floor. What is on the other side of the wall? What is on the other side of the wall? It is the question every child asks the first time they hear that the universe has an edge, and it is usually met with a pat on the head, and it deserves better because it is one of the deepest questions in all of science, and the answer comes in 2 parts. And the first part is a gentle correction that changes the whole shape of the thing. The wall is not an edge. Let me say that as clearly as I can. The cosmic microwave background, the boundary of the observable universe, 46 billion light years away, is not a place where the universe stops. There is no barrier there, no rim, no wall of stone, nothing to run into, nothing to fall off. It is not an edge of space at all. It is a horizon, and a horizon is a completely different kind of thing than an edge, and the difference is everything. So let us use the oldest and best comparison there is, the sea. Stand on the deck of a ship in the middle of the ocean and look out, and you see a perfect circle around you, the horizon, the line where sea meets sky, and beyond it you can see nothing. The ocean simply ends, as far as your eyes can tell, in a clean edge all around you. But you know, of course, that the ocean does not end at the horizon. The horizon is not a wall. It is just the limit of how far your particular eyes can see from your particular spot, curved away by the shape of the world, and the sea continues far beyond it. Exactly the same. More water, more waves, ships you cannot see, shores you cannot see. And if you sail toward the horizon, you never reach it. It recedes ahead of you, always the same distance away. Because it was never a place. It was a limit of seeing, and it travels with you, centered always on you, wherever you go. The edge of the observable universe is exactly this. It is a horizon, not an edge. It is the limit of how far our particular eyes can see from our particular spot, curved away not by the shape of the world, but by the age of the universe, by the simple fact that light has only had 13.8 billion years to travel. And beyond that horizon, the universe continues exactly the same. More galaxies, more stars, more cosmic web, worlds we cannot see, light that has not had time to reach us. And if we could somehow travel toward that horizon, it would recede ahead of us, always 46 billion light years away. Because it was never a place, it is a limit of seeing, and it is centered always on the observer. Every measurement we can make confirms this. In every direction we look, as far as we can look, the universe appears essentially the same kinds of galaxies, the same great web of clusters and voids, the same physics, the same texture, with no hint of thinning out, no gradient toward any edge, no sign whatsoever that we are near any boundary, or that the cosmos is wrapping up just past our sight. The universe beyond our horizon almost certainly continues ordinary and unremarkable, in a galaxy sitting right at the edge of our vision. One whose ancient light is only now arriving is an utterly ordinary galaxy, surrounded by more galaxies. some of which lie beyond our horizon and are therefore invisible to us forever. And to any astronomers living in that far galaxy, their own horizon would stretch 46 billion light-years around themselves, taking in vast regions we can never see, and to them we would be the ones near the edge of their bubble, or beyond it. So the wall is not the size of the universe. The wall is the size of our sight, and that changes the question, sharpens it, because now we are no longer asking where the universe ends. We are asking a harder thing. If the universe continues past everything we can ever see, then how much more of it is there? And the honest pursuit of that question leads to two possible answers. And the first is merely staggering, and the second has no bottom at all. So how much more universe is there, beyond the part we can see? The first way to answer is to measure, and remarkably we can, at least a little, because the shape of the whole universe leaves a fingerprint on the light we can see, and reading that fingerprint sets a floor, a minimum, on how big the whole thing has to be. Here is the idea. According to Einstein, space can be curved, bent the way the surface of the Earth is curved, and a universe can have one of three overall shapes on the largest scale. It can be curved like the surface of a ball, closing back on itself, which would make it finite, so that a traveler going straight in one direction would eventually arrive back where they started, the way you can circle the Earth and come home. Or it can be curved the other way, like a saddle, opening outward forever. Or it can be flat, perfectly flat, like an endless sheet extending without limit in every direction. And which of these our universes turns out to be measurable, because the geometry of space affects how light travels across it, subtly bending the paths of the ancient light from the cosmic microwave background, changing the apparent sizes of the faint ripples in that first light in a way that depends on the curvature. And cosmologists have measured those ripples with breathtaking precision, and the answer that comes back is clear. As far as we can measure, the universe is flat, not curved like a ball, not curved like a saddle, flat to within a tiny margin of error, so flat that no curvature can be detected at all. And this matters enormously for our question, because it sets that floor. If the universe were curved like a ball, finite, closing back on itself, then the strength of that curvature would tell us its total size. The way measuring the curve of the ground can tell you the size of the planet you stand on. But the curvature we measure is essentially zero. The ground looks flat as far as our instruments can see, and a flat or nearly flat universe cannot be small, because a small closed universe would show obvious curvature, and ours shows almost none, which means the whole universe must be, at the very least, vastly larger than the part we can see, large enough that its curvature is too gentle to detect across the entire 93 billion light-years of our visible bubble. The way the curve of the Earth is undetectable to an ant standing on a football field. The most careful analyses of that flatness give a minimum, a conservative floor, and the floor is this. The whole universe is at least 250 times bigger in diameter than the observable universe, which means at least 15 million times bigger in volume. And that is the minimum, the smallest it is allowed to be, given what we measure, the floor beneath which it cannot go. Sit with that for a moment, because it is a strange kind of number, a humble number, a number that says at least. Everything we can see, the 93 billion light-years, the 2 trillion galaxies, the septillion stars, the whole visible cosmos that already broke your mind tonight, is at the most generous a 15 millionth of the whole. And that is the conservative estimate, the careful one, the one that leans as small as the evidence allows. The visible universe is to the whole universe as a single grain of sand is to something far larger than a beach, and that is the floor. The ceiling, as we are about to see, may not exist at all. Now the ceiling, or the lack of one, and this is where the question, how big is the universe, opens all the way up and reveals that it may have no answer at all. Not because we are ignorant, but because the true answer might be a word rather than a number, and the word is infinite. Let us approach it through the leading theory of the universe's very first instant, a theory called inflation because it is where the possibility of an endless universe comes from, and it is beautiful. Inflation proposes that in the first unimaginably tiny fraction of a second of the universe's existence, far less than a trillionth of a second, space underwent a burst of expansion so violent, so explosive that it doubled in size and doubled again. And again, dozens of times over, in less time than light takes to cross a single atom, taking a region smaller than a subatomic particle and stretching it almost instantly to something vast. Inflation was proposed to solve several deep puzzles about the universe, and it solves them elegantly. It explains why the universe looks so uniform in every direction, why it is so flat, why the ripples in the ancient light have exactly the pattern they do, and it has passed test after test, and it is our best account of the beginning. And inflation comes with a staggering implication. The region that inflated to become everything we can see, our entire 93 billion light-year bubble, was a tiny, tiny patch of a much larger inflating hole. And there is no reason for the inflation to have stopped at the edge of our patch. Every reason to think it went on, producing far more space than we can ever see, so much more that the numbers stop being numbers. Our whole observable universe becoming a speck within a totality, trillions upon trillions of times larger. And in many versions of the theory, the most natural versions. The total is not merely huge but genuinely infinite, endless, without limit in any direction. And here is what a truly flat universe suggests all on its own, without any theory of the beginning at all, just taken at face value. A perfectly flat universe, if it is flat everywhere and does not secretly curve back on itself somewhere far beyond our sight, is infinite. It has to be. A flat sheet that never curves has no edge and no end. It goes on forever. And since we measure our universe to be flat, the simplest reading of that measurement, the most straightforward interpretation, is that space extends without limit, infinitely, in every direction, that there is no total size, no number, no edge, no all of it, only more and more and more forever. Let me try to say what infinite actually means here, because it is easy to say the word and let it slide past, and it deserves to land. If the universe is truly infinite, then there are infinitely many galaxies, not 2 trillion, infinitely many, and infinitely many stars, and infinitely many worlds. And our entire observable universe, the whole visible cosmos of 2 trillion galaxies, is not a small fraction of the whole. It is zero fraction of the whole. Any finite thing, however large, divided by infinity, is nothing. And so the honest mathematical statement, if the universe is infinite, is that everything we can see, everything we have ever seen or will ever see, all of it together, is precisely 0% of what exists. An infinitely small sample of an endless whole, a single drop claiming to describe an ocean that has no shore. We cannot confirm this. That is the crucial honesty. We can never confirm it because we can never see beyond our horizon. And it remains possible that the universe is finite but merely enormous, curving back on itself so gently, so far beyond our sight, that we simply cannot detect the curve, the way the ancient world could not detect the curve of the earth and thought it flat. But the measurement says flat, and flat says infinite. And the leading theory of the beginning says infinite. And so we are left in one of the strangest positions any question has ever put us in, which is that the answer to how big is the universe may genuinely, honestly, be that it has no size because it has no end, and that we happen to live inside an endlessness, on one drop of an infinite sea, able to see exactly one bubble of it, forever. There is a twist to the story of the horizon, a quiet and slightly melancholy one, and it is worth telling gently because it changes how you might feel about being able to see anything at all. The horizon is not fixed, it is moving, and the direction it is moving is not the direction you would hope. Remember that the universe is expanding, and here's the part we have not yet added. The expansion is speeding up. It is accelerating, driven by a mysterious something that fills all of space, that astronomers call dark energy and honestly do not fully understand. And what it does is push the galaxies apart faster and faster over time. And this acceleration is doing something profound and a little sad to the map we have drawn tonight. It is carrying distant galaxies away from us faster and faster. And for the most distant ones, the space between us and them is now stretching faster than their light can cross it, which means their light will never reach us, no matter how long we wait. And they have crossed a boundary even more final than the edge of sight, the boundary of reachability, beyond which nothing they do can ever affect us, and nothing we do can ever affect them. We can still see them for now, because we are receiving old light they sent long ago. But that light is the last we will ever get, growing fainter and more stretched, and eventually it will fade beyond detection, and they will vanish from our sky. Not by moving, but by the growing of the dark between us. Astronomers have done the accounting, and it is sobering. Of all the galaxies we can currently see, the vast majority, something like 94% of them, are already beyond our reach. Already so far that a signal we sent today, traveling at the speed of light, could never catch them. We can see them, but we can never touch them, never reach them, never send anything to them or receive anything from them again. They are visible ghosts present in our sky, absent from our future. And every year the acceleration carries more of them across that line, silently, out of reach. And in the far, far future, the process completes itself. Hundreds of billions of years from now, the acceleration will have carried every galaxy outside our own local neighborhood so far away, so fast that their light will no longer reach us at all. And the sky beyond our own gravitationally bound cluster of galaxies will be simply empty, black, and any astronomers alive in that distant era, looking out from whatever worlds exist then, will see no other galaxies, no cosmic web, no ancient background light, none of it. Only their own island of stars floating in a darkness that appears to have no contents whatsoever. And they will conclude from perfect observations, honestly interpreted, that their galaxy is the entire universe, alone in the void, and they will be wrong, and they will have no possible way of knowing they are wrong, because all the evidence will have receded beyond the horizon forever. Which means, and this is the thought I want to leave you with before we turn back toward home and comfort, that we are living in a special time, a window, a golden age of seeing. We arrived early enough in the universe's life to catch the light of the other galaxies before the expansion hides them. Early enough to detect the ancient glow of the beginning before it stretches into nothing. Early enough to read the true story of the cosmos while its pages are still open. The knowledge we have gathered tonight, the expanding universe, the deep field, the wall of first light, the possibly endless hole, all of it is knowledge with an expiration date, visible now, fading slowly, destined to become permanently unknowable to whoever comes after. The universe is a book that is very slowly closing itself. And we tonight, you and I, are among the lucky readers who arrived while the light was still good enough to read by. And there is something almost unbearably poignant in that, and also something like a gift. Let us return to that strange fact from earlier, the one I asked you to hold, because it deserves its own quiet minutes now, and it is one of the most mind-bending consequences of everything we have built tonight. You are at the center of the observable universe. Not figuratively, literally, geometrically, precisely. Light reaches you from all directions equally, and so the sphere of everything you can see is centered exactly on you, on your eyes. 46 billion light years of visibility in every direction around this one point, which is wherever you happen to be sitting or lying right now. You are the center of your cosmos, and so am I at my spot. And so is every other person on Earth, each of us at the center of a bubble almost identical to everyone else's. Because on the scale of the whole universe, the entire Earth is a single point, and we all share essentially the same view. But now go farther. A being on a world in the Andromeda Galaxy, 2.5 million light years away, sits at the center of their own observable universe. A bubble 46 billion light years in radius centered on them, and their bubble overlaps enormously with ours. But it is not the same. It is shifted. It reaches 2.5 million light years farther in their direction and falls 2.5 million light years short in ours. So their bubble contains distant regions that ours will never include, and ours contains regions theirs never will. And a being in a galaxy near the edge of our observable universe, 46 billion light years away, sits at the center of a bubble that barely overlaps ours at all. A bubble reaching out into vast territories we can never see. Entire domains of galaxies utterly beyond our horizon, ordinary and shining and forever invisible to us. And to them we sit at the very edge of sight, or beyond it, a faint ancient smudge if we are visible at all. There are, in other words, as many observable universes as there are points in space to observe from, which if the universe is infinite means infinitely many of them. each centered on its own observer, each a slightly different sphere of visibility, all overlapping, all sliding past one another. A cosmos not of one center but of endless centers. No two quite alike, and no privilege point anywhere. No true middle. No place that is more the center than any other. Because every place is the center of its own view, and no place is the center of the whole. Because the whole, if it is infinite, has no center, cannot have one, the way an endless line has no middle. And there is a deeper loneliness folded into this, and a deeper wonder too. Every observer in the cosmos is sealed inside their own bubble of visibility, able to see only their own sphere. And for the distant ones, those bubbles never meaningfully touch, so that the universe is partitioned, divided by the finite speed of light and the finite age of time into countless overlapping spheres of sight. And no observer can ever see the whole ever. Not with better telescopes, not with more time, because the limit is not technological, it is woven into the structure of space and time themselves. Each of us gets one bubble, one sphere of the endless, one view of the infinite, centered on ourselves, ours alone, shared fully with no one who is not standing essentially where we stand. And rather than let that feel isolating, I want to turn it gently the way tonight keeps turning things. Because there is another way to hold it. You are at the center of a universe. A real one. 93 billion light years wide. 2 trillion galaxies arranged in a perfect sphere around you. The oldest light in existence glowing at its every edge. All of it centered precisely on the place where you are breathing right now. And while that is true of everyone, it is still also genuinely, truly true of you. And there is a very old feeling that humans have always had, lying under the stars, the feeling of being small and off to the side and unimportant in a vast, indifferent cosmos. And it turns out to be, in the most literal astronomical sense, exactly backwards. You are not off to the side of the universe. There is no side. You are and have always been and will always be at the very center of everything you can see. It is worth stopping to ask how we could possibly know any of this. Because every number tonight, the 93 billion light years, the 2 trillion galaxies, the flatness, the expansion, was measured by creatures who have never left the immediate neighborhood of a single small planet, who cannot travel to a single one of these places. And the way they did it is one of the great quiet adventures of our species, and knowing it makes the numbers trustworthy rather than magical. So let us walk it briefly. It is called the Cosmic Distance Ladder, and it is exactly what it sounds like. A ladder, each rung of measurement built on the rung below, reaching from the ground beneath our feet all the way to the edge of the visible universe. And its bottom rung is something you can do with your own hand. Hold up a finger at arm's length, close one eye, then switch eyes, and watch your finger jump against the background. And notice that if you bring your finger closer, it jumps more, and farther, it jumps less. That jump, called parallax, is a ruler, because the amount of the jump depends precisely on the distance. And astronomers do exactly this with nearby stars, photographing them from one side of Earth's orbit, and then, 6 months later, from the other side, 300 million kilometers away, and measuring the tiny jump of the star against the more distant background in pure geometry. The same geometry as your finger hands them the distance. No assumptions, just triangles. That is the first rung, and it reaches the nearer stars. For the farther ones, we climb to a second rung, built on a discovery made by a woman named Henrietta Leavitt in the early 1900s, working at Harvard analyzing photographic plates for low wages, forbidden as a woman from operating the great telescopes herself, who noticed that a certain kind of pulsing star, one that brightens and dims in a steady rhythm, keeps a perfect secret in its rhythm. The speed of its pulsing reveals its true brightness, so that by watching the star blink, you can know exactly how luminous it really is, and by comparing how bright it truly is to how bright it appears. You can know how far away it must be, the way you can judge the distance to a lighthouse if you know the true strength of its lamp. These pulsing stars are bright enough to be seen in other galaxies, and they let us measure the distances to galaxies for the first time. And it was these very stars that let Edwin Hubble prove that Andromeda was a separate galaxy far outside our own, and then measure the expansion itself. The whole story tonight resting on the pattern found by a woman who was never allowed to look through the telescope. And beyond those stars, a third rung, a certain kind of exploding star, a supernova that always detonates with nearly the same true brightness. A standard candle bright enough to be seen halfway across the observable universe, calibrated against the pulsing stars, calibrated against the parallax, calibrated against the width of Earth's orbit. And it was these exploding stars that revealed, in 1998, that the expansion is accelerating. The discovery of dark energy, a Nobel Prize resting on a ladder whose bottom rung is a finger held at arm's length. And I want you to feel what kind of achievement this is, because it is the answer to anyone who wonders how we could dare to claim the size of the universe. We did not guess. We did not leap. We climbed, one careful rung at a time, each measurement checked against the one below it, from a finger to a pulsing star to an exploding star to the edge of everything. 100 years of patient work by people no smarter than you, whose intuitions failed them exactly as often as yours fail you, who simply refused to stop checking. And the ladder holds, and its lower rungs are still being tested and retested today. And that is why the numbers of tonight, impossible as they feel, are not stories. They are measurements honestly made by a small, curious species that could not leave home and measured the size of everything anyway. Let us spend a little while with the machines that measured all of this, the great telescopes, because there is a wonder in what they actually do that gets lost in the numbers. And it is the purest form of the time travel we spoke about at the very beginning of the night. A telescope, remember, does not see faraway things. It sees old light. And so the bigger and better a telescope is, the fainter the light it can gather. And the fainter the light, the farther it has traveled. And the farther it has traveled, the older it is, which means that our greatest telescopes are, in the most literal and precise sense, our deepest time machines. And they are pointed not at the present universe, but at the past. Layer by layer, the deeper they look, the earlier the era they see. The Hubble Space Telescope, staring at that empty speck of sky for 10 days, gathered light that had traveled for over 13 billion years, showing us galaxies as they were near the dawn of the cosmos, small and blue and forming, the toddlers of creation. And we saw them not as they are now, because as they are now, they are grand spirals and ellipticals, much like our own, aged 13 billion years. But as they were then, in their infancy, because that is the age of the light, that is when it left. And its successor, the James Webb Space Telescope, launched at the end of 2021, was built specifically to see deeper, to catch light even fainter and even older, stretched so far by the expansion of the universe that it has shifted out of visible light entirely into the infrared. And Webb was designed to feel that ancient warmth, and it has shown us galaxies whose light left them more than 13.4 billion years ago, within the first few 100 million years after the beginning. Some of the very first galaxies that ever formed, baby galaxies from the dawn of time, photographed by a machine floating 1 million miles from Earth, built by a species that did not exist for more than 99.9% of the time that light was in flight. Think about what that actually means, because it is staggering when you slow down and hold it. There is light that left a young galaxy 13 billion years ago, when the universe was new, and it crossed the expanding dark for 13 billion years, longer than the Earth has existed, longer than the Sun has existed. And during that immense journey, a star formed, our Sun, and around it a small world gathered. And on that world, life appeared and struggled and evolved for billions of years, and became fish and forests, and creatures that walked, and eventually a species that stood up and grew curious, and slowly over thousands of years, learned the laws of light and built glass and metal instruments, and lofted one of them above the atmosphere, and aimed it at exactly the right patch of sky, and opened its eye at exactly the right moment to catch that particular ancient light in the very instant it finally arrived, after 13 billion years at the end of its journey. The timing of that is almost beyond belief. That light traveled for 13 billion years, and we came into existence and built the telescope and caught it in the cosmic blink where all of that overlapped. A little earlier in cosmic history, and there would have been no one here to catch it. A little later, and as we learned, the expansion will eventually carry that ancient light beyond reach entirely. We are here in the exact window when the deepest past is still catchable, and we built the nets to catch it. And we did, and the baby pictures of the universe are sitting on our servers tonight, gathered by patient machines in the cold above the earth. And any night you wish, you can look at them. The first galaxies. The dawn of everything. 13-billion-year-old light, caught at last by the curious latecomers it had been traveling toward, without knowing it, since before the Earth was born. There is a question that rises naturally out of all this vastness, and it deserves a real answer rather than a shrug, because many people confronting the true size of the universe for the first time feel something that is almost hurt, a sense of being mocked by the scale, reduced to nothing, and the question they ask is, why is it so big? Why this absurd, extravagant enormity, trillions of galaxies, endless space, when one small world under one small sun would seem to be all that a life like ours requires? Why the waste? And there is a stunning answer, and it comes not from philosophy, but from physics. And it is this: the universe has to be this big for you to exist at all. The size is not extravagance. The size is a requirement. Here is the reasoning, and it runs straight through your own body. You are made of complex atoms, carbon in every cell, oxygen in your blood, calcium in your bones, iron carrying breath through you at this moment, and none of those atoms existed when the universe began. The early universe made only the two lightest elements, hydrogen and helium, and nothing else. No carbon, no oxygen, no iron. None of the ingredients of life or worlds. Every heavier atom, everything you are built from, was forged afterward inside stars, cooked in their nuclear cores over billions of years, and then scattered into space when those stars died, so that the next generation of stars and planets could form from the enriched ashes. Your body is, quite literally, made of the dust of dead stars, and making that dust takes time. Billions of years of stars living and dying, generation after generation, before there was enough of the heavy elements to build a rocky world with oceans, and then more billions of years for such a world to form and cool and grow life, and then more billions still for that life to climb from the first cells all the way to a creature that can look up and ask how big the universe is. The minimum age for a universe that contains someone like you is measured in many billions of years. And now the two ideas lock together, because the universe is expanding and has been expanding the entire time, which means its age and its size are welded to each other, inseparable. A universe billions of years old is necessarily billions of light years across, because it has been growing every single moment of those billions of years. You cannot have a universe old enough to have made you that is not also enormous, any more than you can have a person who has been walking for 8 hours but has not gone anywhere. The vast dark distances that make you feel so small, the billions of light years of apparent emptiness, are the direct physical signature of the time it took to build you. And every light year of that darkness is time that was spent, in part, forging the atoms now assembled into the mind considering this. The universe is enormous because it is old. And it is old because that is how long you take to make. And so when you feel small under the night sky, you are, in the most precise possible sense, feeling the size of your own beginning, the enormous patient duration that the cosmos required to arrive at last, at you. The emptiness is not indifference. The emptiness is the measure of your own making, and the scale that seems to diminish you is, read correctly, the scale of what it costs to have you here at all. If the universe may be infinite, you might think we have reached the largest possible idea, the end of the road of bigness, and remarkably, we have not, because there are serious scientific ideas in which our entire universe, infinite or not, is only one of many. And honesty requires touring them, carefully marking clearly where measurement ends and speculation begins. Because this is the frontier where even physicists disagree, and it is worth visiting precisely because it shows how far the question, how big, can go. The first idea comes straight out of inflation, the theory of that first violent instant of expansion, because in many versions of the theory, inflation does not happen only once. It happens perpetually, eternally, in a vast inflating backdrop, and every so often a region of it stops inflating and settles down into a universe, a bubble like ours, while the space around it goes on inflating and spawning other bubbles endlessly, so that our entire cosmos, our whole possibly infinite universe, is a single bubble in an eternally inflating foam, one of countless bubble universes, each forming its own pocket of settled space forever. And the bubbles may have different properties, different strengths of forces, different physics, most of them lifeless. A few like ours, tuned by chance in a way that allows stars and worlds and minds. This is called eternal inflation, and it is not idle fantasy. It is a natural consequence of the same inflation theory that successfully explains the flatness and uniformity of our own universe, which is what makes it worth taking seriously. Though we must be honest, we cannot see the other bubbles. We may never be able to, and whether they are real remains genuinely unknown. A second idea comes from the strange mathematics of the very small, from quantum mechanics, in which, on some interpretations, every quantum event that could go more than one way does go every way, each possibility splitting off into its own branch of reality, so that reality is constantly branching into countless parallel versions, a different history in each. And this too is called a multiverse, a different kind layered not in space but in possibility. And it too is untested and perhaps untestable, and taken seriously by some careful physicists and doubted by others. I am telling you about these ideas not to claim they are true, because I cannot, and no one can, not yet, and maybe not ever, but because they show you something about the question we started with. How big is the universe turns out to be a question that keeps opening doors, each one revealing a larger room, the planets giving way to the galaxy to the 2 trillion galaxies, those to the possibly infinite whole beyond the horizon, and that, perhaps, to an endless foam of other universes beyond even this one. And at every stage, just when the mind thinks it has found the outermost wall, the wall turns out to be another horizon, with more beyond it. And I find, and maybe you will find, that there is a strange peace in this, rather than terror, because it means the answer to how big is the universe is not a number that could ever crush you with its size. It is an open door, an invitation, a mystery that gets deeper the more honestly you look, and a mystery that deep is not a thing that makes you small. It is a thing that makes you curious, and curiosity, unlike fear, is a feeling you can fall asleep inside, wondering at ease about rooms beyond rooms beyond rooms, none of which you have to enter tonight, all of which will still be there, waiting, patient, endless, in the morning. Before we turn toward home, I want to show you the largest things that actually exist inside our visible bubble, the biggest structures the universe has ever built, because we have talked about the whole and about the edge, but we have not yet met the true giants that live in between, and they are worth meeting quietly because they are almost beyond belief and they are entirely real, mapped, measured, sitting in the data tonight. Start with how galaxies are arranged, because they are not scattered randomly through space like grains thrown on a floor. They are gathered by gravity over billions of years into a pattern, the largest pattern there is, called the cosmic web. Galaxies collect into groups, groups gather into clusters, clusters string together into long glowing threads called filaments, rivers of thousands of galaxies flowing across hundreds of millions of light years. And the filaments meet at bright dense knots, the great clusters, and wrap around enormous empty regions called voids, vast rounded hollows of near perfect nothing, so that the universe on the largest scale looks like a foam, a sponge, a network of luminous threads surrounding dark bubbles of emptiness. And this is not metaphor, it is the measured structure of everything, the actual arrangement of the 2 trillion galaxies, a cosmic web filling the whole visible universe. And the voids are worth a moment of awe all by themselves, because they are the emptiest places that exist, and some of them are almost incomprehensibly large. There is one called the Bootes Void, a roughly spherical hollow in the cosmic web about 330 million light years across, containing almost nothing, a great bubble of emptiness so vast that it has been said that if our own galaxy had formed at its center, we would not have discovered that other galaxies existed until well into the 20th century, because there would have been almost nothing near enough to see. Our astronomers gazing out into what would look like an empty cosmos, alone. In the filaments, the threads between the voids, include structures that strain even the language of astronomers. Walls of galaxies so long that their names sound like exaggerations. The Sloan Great Wall, a filament of galaxies over 1 billion light-years long, and a disputed but possibly real structure so vast, up to 10 billion light-years across, a large fraction of the entire observable universe. That its existence troubles our theories because there may not have been enough time since the beginning for gravity to have assembled anything so enormous, and its reality is still argued over in the journals tonight. And running through all of it, through every filament and knot and wall, is the deepest open secret of the cosmic web, which is that the glowing galaxies are not the main thing. The web is built, held together, sculpted by an invisible substance that outweighs all the ordinary matter, all the stars and galaxies and gas, by about 5 to 1, a mysterious something that gives off no light and that we call dark matter, whose gravity built the web in the first place. And the galaxies, all 2 trillion of them, are merely the luminous froth riding on top of an unseen ocean, the visible trim on a structure made mostly of something we cannot see and do not yet understand. So even the grand map of everything, the cosmic web, the largest structure there is mostly invisible, mostly mysterious, mostly dark, and the shining part, the galaxies, the part that took our breath away tonight with its 2 trillion islands and its septillion stars, is only the small glowing minority of what is actually out there, holding the whole vast web together in the dark. Let us find ourselves in all of this, because we have measured the whole and stood at the edge, but we have not yet written down our own address, and doing so, slowly, is a strangely settling thing, the way saying where you live out loud can make a vast, strange city feel, for a moment, like home. So here is your address written out in full, from the near to the far. You are on the Earth, the 3rd small world from an ordinary star. That star, the sun, is one of a few 100 billion stars in a galaxy called the Milky Way, and you sit about 26,000 light-years from its center, out in a quiet minor spiral arm, far from the crowded, radiation-soaked downtown around the galactic core, in the calm suburbs, which is very likely part of why you're here at all, because the peaceful outskirts are where a world can hold still long enough for life to take its slow billions of years. Your galaxy, the Milky Way, is not alone. It has a large companion, the Andromeda Galaxy, and a few dozen smaller ones, and together they form a little gathering called the Local Group, a cluster of galaxies bound together by gravity, spread across several million light-years. And the Local Group is itself only a small outlying member of something much larger, a great collection of thousands of galaxies centered on a dense region called the Virgo Cluster, all of it together forming a supercluster over 100 million light-years across. And that supercluster, astonishingly, turned out just a decade ago to be merely one lobe of something vaster still, an enormous flow of 100,000 galaxies, all drifting together through space, which astronomers named Laniakea, a Hawaiian word meaning immeasurable heaven, 500 million light-years wide, and you tonight, along with your planet and your star and your whole galaxy, are drifting as part of that immense slow river of 100,000 galaxies, being carried through the cosmos at hundreds of kilometers per second toward a distant gravitational something we can barely see. And Laniakea is one structure among countless others woven into the cosmic web, and the cosmic web fills the observable universe. And the observable universe is a bubble 93 billion light-years wide, at least a 15 millionth of the whole, and the whole may have no end at all. That is your address. You live on a planet, orbiting a star, in the suburbs of a galaxy, in a small group, on the edge of a cluster, within a supercluster, inside the Laniakea flow, woven into the cosmic web, near the center of your observable universe, which is one bubble of a whole that may be infinite. Read it back slowly, from the top, and notice what happens as you do, because something gentle occurs when you actually name the whole chain, room by room, out to the endless edge. The vastness stops being a single overwhelming blur and becomes a sequence, a nested set of homes, each one holding the last like a child's set of wooden dolls, and you are the smallest doll, safe inside all the others, the room inside the house, inside the town, inside the country, inside the world, inside the galaxy, inside the cluster, inside the endless whole. And every one of those walls, every scale of the nesting, is not a thing that diminishes you. It is a thing that holds you. And the universe, for all its terrifying size, turns out when you write down your place in it honestly to be less like an abyss you are lost in and more like a very, very large set of nested rooms, in the innermost of which, tonight, wrapped in blankets, one small awake thing is drifting off to sleep, held by all of it. Here is a question you have probably never asked, because the answer feels obvious, and the obvious answer is wrong. How fast are you moving right now? Lying still, resting, perfectly motionless, the answer feels like zero. And it could hardly be more mistaken, and unpacking how mistaken is one of the loveliest quiet facts to fall asleep on, because it means that even now, even at your stillest, you are a traveler through the vast universe we have been measuring, and you always have been. Start close. The Earth is spinning, and at most latitudes it is carrying you eastward at hundreds of kilometers per hour, faster in the tropics. And you feel none of it, because everything around you moves with you. But that is only the beginning. The spinning Earth is also racing around the sun, and its speed in that orbit is about 30 kilometers every second, 107,000 kilometers per hour. So that since this video began, you have traveled thousands of kilometers around the sun, sitting perfectly still. And the sun itself, carrying the Earth and you, is not fixed either. It is orbiting the center of the Milky Way, sweeping through the galaxy at about 230 kilometers every second, 800,000 kilometers per hour. So vast a motion that one full orbit, one galactic year, takes 230 million years. And the last time the sun was in the position it occupies tonight, dinosaurs had not yet appeared on Earth. And the galaxy itself is moving, falling toward its neighbor Andromeda, and the whole local group is streaming through space as part of the Laniakea flow. And when astronomers add up all of it and measure our total motion against the most fundamental reference there is, the ancient light of the cosmic microwave background itself, the oldest light in the universe, they find that our galaxy, with everything in it, with you in it, is moving through the cosmos at about 600 kilometers every second, more than 2 million kilometers per hour, toward a particular point in the southern sky. 2 million kilometers per hour. That is your true speed right now through the universe while you lie perfectly still under your blankets. You have never been still. Not once in your entire life, not for a single second, has any part of you been at rest. Because there is no rest anywhere in the universe. No fixed point to be still against. Everything moving, everything flowing, the Earth spinning and circling, the sun sweeping, the galaxy falling, the whole local group streaming through the endless dark at 2 million kilometers an hour, and you carried along by all of it at once, layer upon layer of motion compounded together, are the fastest still thing imaginable. A traveler who never stops traveling, even in sleep, especially in sleep. And there is something gentle in this, not unsettling, but soothing if you let it be, because it means that resting is not the opposite of journeying. You do not have to go anywhere to be a traveler through the universe. You are already on the greatest voyage there is, aboard the Earth, aboard the sun, aboard the galaxy, moving through more of the vast cosmos every second than any spacecraft could carry you in a lifetime. And the voyage asks nothing of you, no effort, no destination, no staying awake to steer. It simply carries you, has carried you every moment of your life, and will carry you every moment still to come. 2 million kilometers an hour through the immeasurable heaven, warm and held and moving even now, even as you begin, at last, to drift towards sleep. Let us rest from the great ideas for a while, because this is a journey for the end of the day. And I want to spend a few slow minutes simply standing at the scales, one after another, letting each one settle in the body before the next. The way you might pause on each landing of a staircase to catch your breath. Begin here in your room, with the walls you can touch, the space you know, a few meters across, the scale your body actually understands, the only scale it was ever built for. Now rise gently and see your building, your street, the pattern of your town or city spread below, the scale of a life of errands and neighbors, and the walk to somewhere familiar. And already, at just this height, individual people have become invisible. Rise more and see your whole country, its coastlines and mountains, a shape you know from maps, and then the whole Earth, the blue and white marble hanging in black, the entire world of every human who has ever lived reduced to a ball you could cover with a thumbnail. Every war and love and life that ever happened, all of it on that one marble. And this is the view that changed every astronaut who ever saw it, and you are seeing it in your mind, for free in the dark. Keep rising, the Earth shrinks to a blue dot, then to a point, then it is gone, lost in the glare of the sun, and the sun itself becomes one star among its neighbors, and then those neighbors gather into the great wheel of the Milky Way. Our galaxy, hundreds of billions of stars turning slowly in a luminous spiral, and the whole of it, every star you have ever seen with your naked eye on every night of your life, is a tiny patch of one arm of that wheel, and now the wheel itself shrinks, becomes one glowing coin among others. Our galaxy joining its neighbors, the little cluster of galaxies we belong to, and that cluster joining greater ones. Thousands of galaxies flowing together, and those gathering into the vast lacework of the cosmic web. The largest pattern there is, glowing threads of galaxies wrapped around enormous dark voids. The whole universe resembling, from far enough away, something between a sponge and a network of neurons, luminous filaments meeting at bright knots, surrounding great hollows of nothing, on in every direction. And keep rising all the way out until the entire observable universe hangs before you. The whole 93 billion light-year bubble, 2 trillion galaxies. The wall of first light glowing faintly at its every edge. The complete visible cosmos held at last in a single view, like a luminous seed. And then remember what tonight has taught you, that this seed, this entire visible everything, is at the very least a 15 millionth of the whole, and possibly an infinitely small speck of an endless sea. And let the rising stop there, because there is nowhere left to rise to. Only more forever, past the horizon, and now gently begin to fall. Back down through the web, into the cluster, into the galaxy, down the spiral arm, past the neighboring stars, to the sun, to the blue dot growing into a marble, growing into a world, down through the clouds, to your country, your town, your street, your building, your room, your bed, your breath, and stop here, exactly where you started. One small, warm, awake thing on one small world, and understand that you did not shrink during that journey, and you did not grow. You stayed exactly the size you are, the size that can hold a cup and a hand and a thought, and that this modest human size, neither vast nor tiny but somewhere in the strange middle, is the only size in the entire universe that we know of that can do the one thing the whole endless cosmos cannot do for itself. Notice how big it is, feel it, and be moved. There is a direction we have not yet traveled tonight, and it is just as vast as the one we have spent all this time climbing, and it runs the other way, downward into the small. Because the question, how big is the universe, has a hidden twin. How small does it go? And the answer turns out to mirror everything we found in the sky. And it ends with a revelation about the chair you are sitting in and the body you are resting. Start with your own hand again. Zoom in past the skin to a single cell, one of the roughly 37 trillion that make up your body, each one a bustling microscopic city, and then zoom into the cell, past its machinery, down to a single molecule, and then to a single atom. And here the numbers detonate again, because the atom is almost unimaginably small, so small that there are more atoms in a single glass of water than there are glasses of water in all the oceans of the earth, more atoms in one sip than sips in every sea. And your body holds about 7 octillion of them, a 7 followed by 27 zeros, which means, and this is a lovely coincidence, that the number of atoms in your one body is not far from the number of stars in the entire observable universe. You are, in a numerical sense, a universe of atoms contemplating a universe of stars, and the two counts nearly match. And then the atom reveals its secret, the same secret the sky has been keeping all along. Picture an atom the way the old diagrams drew it, a dense little center with tiny electrons whirling around it. And now understand the true proportions, because the diagrams lie by crowding. An atom is almost entirely empty space. If you enlarged a single atom until its center, its nucleus were the size of a marble sitting in the middle of a great stadium, the electrons would be tiny specks flickering somewhere out past the highest seats. And between the marble and the seats, there would be nothing at all. Pure emptiness. The vast majority of the atom, more than 99.999% of it, empty space. Which means you are too. The chair holding you, the floor beneath it, the walls of your room, your own body, all of it is overwhelmingly, almost entirely nothing. A haze of unimaginably tiny specks of matter suspended in enormous emptiness, held apart and given the feeling of solidity by invisible forces. So that when you press your hand against the bed, the solidity you feel is not matter touching matter. It is the electric fields of near-empty atoms pushing against the electric fields of other near-empty atoms. Two clouds of mostly nothing, refusing to overlap. And here's the symmetry, the thing that ties the whole night together into one shape. We climbed outward and found that the solar system is mostly empty, that the space between stars is almost perfectly empty, that the cosmic web is vast voids threaded with rare glowing filaments, emptiness dotted with rare structure at every scale. And we climb inward and find exactly the same thing, that matter itself, the very stuff of the dots, is emptiness dotted with even rarer specks of substance. Emptiness above, emptiness below, emptiness within. The universe, honestly measured at every scale in both directions, is overwhelmingly empty space. A vast and patient nearly nothing in structure of any kind. A star, a world, a cell, a mind is the rarest and most precious thing there is. A fleeting concentration, an exception fighting quietly against the enormous emptiness. And one of those exceptions, improbably on one small world, has arranged itself into a pattern that can feel wonder about all the rest. And that pattern is you, resting now, mostly empty space, briefly and beautifully arranged into someone who can know it. Since we have learned tonight to think in the deep time of the universe, in billions of years, let us look briefly and gently at what the future holds for the great structures we have measured. Because the universe is not a finished thing. It is a story still being told, and knowing a little of how it continues is, strangely, one of the most settling things of all. The way knowing the shape of a long story lets you rest inside it. Start close with our own galaxy, because it has an appointment. The Andromeda Galaxy, that faint smudge we have returned to all night, is not merely sitting 2.5 million light years away. It is falling toward us, drawn by gravity across the emptiness, approaching at over 100 kilometers every second. And in roughly 4 to 5 billion years, it will arrive. And the two great galaxies, the Milky Way and Andromeda, will meet, and slowly over hundreds of millions of years, they will merge, swinging past each other, drawing back, tangling, at last combining into a single vast new galaxy. And it is one of the loveliest facts in astronomy that in all that collision, almost no stars will actually strike each other. Because stars are so tiny compared to the distances between them, that the two galaxies will pass through one another like two clouds of fine mist mingling, two swarms of gnats crossing in the air, rearranging into something new without a single collision. And any minds alive to watch it, on whatever worlds exist then, will see the night sky slowly transform over millions of years into something more spectacular than any sky in our history. Two galaxies pouring together overhead. And then look further, because the deep future grows stranger and quieter. The expansion of the universe, accelerating, will over vast spans of time carry all the other galaxies, all the ones beyond our own merging local group, farther and farther away, faster and faster until, hundreds of billions of years from now, they have receded beyond the horizon of reachability and even the horizon of sight, and the sky of that far era will be empty of other galaxies entirely. Our own merged galaxy floating alone in a darkness that appears to have no contents at all. And further still, the stars themselves will age and die. The gas to make new ones running out. The galaxy dimming, reddening, going slowly dark over trillions of years, until the universe becomes a vast, cold, quiet place of dim embers and stellar corpses, drifting in an ever-growing dark. And I know that sounds bleak, and I want to turn it. the way tonight has turned everything, because there is a gentler truth folded inside it. That far cold future is unimaginably distant. So distant that the entire age of the universe so far, all 13.8 billion years of it, is not even the beginning of it. A rounding error. A first breath. We are not living near the end of the universe's story. We are living in its opening moments, its first bright morning, while the stars are young and burning and plentiful, while the other galaxies are still visible in the sky, still shining, still close enough to see and study and wonder at, while the true story of the cosmos is still legible in the light. Every generation that has ever complained of being born too late for the great age of exploration has it exactly backward, because in cosmic terms we are the earliest of early risers, awake in the freshest hour of a day that will last trillions of years, and the sky above us, full of visible galaxies and burning stars and ancient readable light, is the richest and most beautiful sky the universe will ever have, and we are here for it now. While it is still bright, and that is not a small piece of luck, it is perhaps the largest piece of luck there is, to be conscious in the morning of the universe with all the lights still on. Let us do something different for a while, the thing this channel loves most, and take an impossible journey together, in the mind, out to the edge of everything. Not as numbers, but as an experience. So, close your eyes if they are not already closed, and let me carry you there slowly all the way to the horizon of the visible universe and back. Begin here at your window and lift. The earth falls away beneath you, the blue marble shrinking, the whole world of your entire life becoming a ball, then a dot, then a fleck of blue lost in the dark, gone, and you are already farther than any human has ever traveled, and we have barely begun. The sun shrinks behind you to a bright star, and then to one point among many, and the whole solar system, the planets, the comets, everything, contracts to a tiny bright knot that vanishes into the starfield. And now you are among the stars of the Milky Way, thousands of them around you, and still you rise and they gather below you into a great glowing wheel. The entire galaxy, 400 billion suns turning slowly in a luminous spiral, and you see it whole, the thing no human eye will ever really see, and it is beautiful beyond speaking, and it shrinks. It shrinks to a glowing coin, and around it appear its companions, Andromeda, the little galaxies of the local group, and they too shrink, joining thousands of others, and the thousands become the shining lacework of the cosmic web, the filaments and the voids. Galaxies now just points of light in a vast three-dimensional web of glowing threads, and still you rise faster now, whole superclusters passing beneath you, Laniakea and its neighbors. The web extending in every direction, on, and you begin to feel how far you have come, and you look ahead, toward the edge, toward the horizon, and here is the strange thing, the thing the journey was for. You never reach it. You fly for what feels like forever, past more galaxies than you could count in 100 lifetimes. And the edge stays always ahead of you, always the same distance away. Because it was never a place, it was a horizon, receding as you chase it. And no matter how far or how fast you fly, there is always more universe ahead. More galaxies, more web, more light, and eventually you understand, out there in the endless flight, that you could travel at the speed of light for the entire age of the universe and never arrive anywhere that felt like an edge. Because there is no edge, only more. And the understanding is not frightening. Out here, it is strangely peaceful, the way the open sea is peaceful. Once you stop looking for land, and so you stop. You stop flying, and you hang there somewhere impossibly far from home, galaxies in every direction, and you turn around, and you look back the way you came, toward home, and you cannot find it. Our galaxy, the Milky Way, everything, is lost somewhere in the uncountable multitude behind you, one glimmer among billions, indistinguishable, and you realize you could never find your way back by sight. That home is not a landmark out here. It is just one more point of light in an endless field of them. And yet, and here is the turn. Here is the gift of the whole journey. Home is still there, real, exact, waiting. one specific point among the billions, with one specific small world, with one specific room, with one specific bed, with you in it, right now, because you never actually left. You only imagined the flight, and the whole endless universe you just crossed is real and out there tonight. And you are real and here tonight, at the center of it. And both of those things are true at once. And now, gently let the journey reverse and fall home, back through the web, into the cluster, into the galaxy, down through the stars, past the sun, to the blue dot, the marble, the world, the room, the bed, and open your eyes, or keep them closed, and feel where you are, one small warm point held at the center of an endlessness you just flew across and could never leave. Because it is home, all of it, the whole immeasurable heaven, and you live here. Everything tonight has been numbers and ideas delivered in the dark, and before we turn toward the close, I want to hand you something you can actually do, because the scale of the universe is not locked away in observatories. It is standing in your own sky, on any clear night, waiting and seeing it yourself. Just once with your own eyes will do more than any hour of listening. The next clear night, step outside, away from the brightest lights if you can, and look up and understand that you are not looking at a flat ceiling of lights. You are looking down a corridor of depth and time, and every point of light in it sits at a different distance, a different age, and here is how to read it, from near to far, using only your eyes. Find the moon if it is up, and know you are seeing it as it was a little over a second ago, the freshest light in your sky. Find a bright planet, Venus low after sunset or Jupiter riding high, and know you are seeing minutes into the past. Sunlight that bounced off another world and crossed to you while you were settling in for the night. Then find the stars, and this is where the corridor opens into depth, because the stars are not all at the same distance, not even close. Find a bright one and know its light may have left it decades ago or centuries, so that you are seeing it as it was before you were born, or before your grandparents were born. The light of a single star carrying across your whole lifetime to arrive in your eye at this exact moment. Some of the stars you can see left their light traveling before the pyramids were built, and it is arriving only now. And then, if your sky is dark enough, perform the deepest act of seeing a human being can perform without any instrument at all. Find the faint band of the Milky Way arching across the sky, the combined glow of hundreds of billions of stars in our own galaxy, so far and so numerous that they blur into a river of light, and know that you are seeing the inside of your own galaxy from within it. And then deepest of all, in the constellation Andromeda, find that faint smudge we spoke of at the very beginning, the neighboring galaxy, and hold, while you look at it, the full truth of what is happening. That 1 trillion stars are delivering their combined ancient light across 2.5 million years of empty space into the small wet lens of your eye, to be focused onto cells that turn it into the experience you are having right now, so that those very particles of light, which left that galaxy before your species existed, are ending their 2.5 million year journey inside your body, this instant becoming part of you. Astronomy is the only science where the thing you study physically enters you as you study it. And when you have found it, notice what your own eyes have just proven. The corridor was real. The moon at a second, the planets at minutes, the stars at years and centuries, the Milky Way at thousands of years, Andromeda at the age of humanity, all of it visible at once, layered in a single dark dome above your house, a complete cross-section of the scale of the universe. From your own breath to the depths of deep time, free on most clear nights, above every roof on Earth. People travel across the world to stand at the edge of a canyon, a single kilometer deep. The canyon above your roof tonight is 2.5 million light years deep, and its far wall is an entire galaxy, and almost no one ever looks up long enough to fall into it. Be someone who looks. Take tonight's numbers outside, attach them to the real lights, and the size of the universe will stop being something you heard in a video and become something that happened to you personally, one quiet night, under the oldest and largest thing there is. I want to spend a few quiet minutes on the light itself, the actual light, the photons crossing the universe right now to reach you, because there is something about them that is easy to state and almost impossible to fully feel. And it may be the most intimate fact in all of astronomy, and it belongs at the end of a night like this. When you look at a distant galaxy, you are not looking at a picture of it. You are catching a piece of it. Light is not an image of a thing sent to you. It is a physical part of the thing. Actual particles, actual energy, made by that object, launched across space. And when that light reaches your eye, it does not show you the galaxy the way a painting shows a face. It arrives from the galaxy and ends inside you. Absorbed, its journey over, its energy becoming a small signal in your nerves. A piece of a distant sun spent at last against the back of your eye, which means that seeing, real seeing, of the deep sky is touch. It is contact. The light of Andromeda that you can find on a dark night is the physical substance of that galaxy, particles that left it 2.5 million years ago, crossing the entire emptiness between arriving tonight and ending, their long flight finished inside your body, so that a part of a galaxy 2.5 million light years away becomes, for an instant, part of you. You are touched every clear night by the actual substance of objects unthinkably far away, struck gently by pieces of 1,000 distant suns. And no one ever tells you this, that to look up is to be touched by the far away, to let the universe end its longest journeys inside your open eyes. And now hold this, because it turns the whole thing into something almost tender. Think about what a long journey that light has made, and what it has passed through, and what it finally found at the end. A particle of light leaves a star in a distant galaxy, and it crosses millions of light years of near-perfect emptiness, past voids where there is almost nothing for 100 million light years in any direction, through the vast dark between the filaments of the cosmic web, for in span of time longer than our species has existed, alone, unchanged, carrying the imprint of the star that made it, and in all that immense crossing, the overwhelmingly likely fate of that particle, given how empty the universe is to continue forever, to fall through the dark for the entire age of the cosmos and never strike anything at all. Never end, never be caught, because matter is so rare and the emptiness so total that most light, most starlight, in the whole history of the universe simply travels forever, unseen, unreceived, falling through nothing toward nothing for eternity, and a vanishingly small fraction of it, almost none of it, by the wildest chance, at the very end of its journey, falls into something rare, something almost impossibly rare, a place where matter has gathered and cooled and arranged itself into a structure that can catch that light and know what it is. An eye attached to a mind on a world, and that light, out of all the endless dark it could have fallen through forever, ends its million-year journey there, in the one kind of place in the universe that can receive it as more than heat, that can turn it into wonder. So when you lie under the stars tonight and let their light into your eyes, understand that you are the rarest possible ending to the longest possible journey. That light which could have fallen through emptiness forever instead found you, and became, in the last instant of its long life, something seen, something known, something that mattered, and that this small transaction, this quiet catching of ancient light by a mind that understands it, is one of the rarest events in the whole vast universe. And it happens freely, quietly, every single time you look up. And it is happening, in a sense, right now in the dark, as you rest, the universe delivering itself to you, and you receiving it. There is one more feeling the size of the universe stirs up that deserves honest attention before we close. And it is a quieter one than awe, and it visits almost everyone who thinks about these scales for long, and it is a kind of loneliness. If the universe is this vast, this empty, this full of distance, then everything is so far from everything else, and we are so far from anyone who might be out there, that the vastness can feel isolating, a great cold separation built into the structure of reality. And it is worth sitting with that honestly rather than waving it away, because there is something true in it, and something untrue, and telling them apart is part of making peace with the sky. What is true is the distance. The nearest star is 4 light years away, and the nearest large galaxy 2.5 million. And if there are other minds out there, other watchers on other worlds, they are almost certainly so far away and so scattered across the vastness of time as well as space that we may never reach them or hear them. Each civilization, if there are others, sealed in its own region, its signals crawling out at the speed of light across gulfs that take millennia to cross, so that even in a universe full of life, every living world might be effectively alone, an island whose nearest neighbor is too far to ever visit, calling across a dark too wide for the call to arrive. That much is honest, and it is a real feature of the scale we have measured. But here is what is untrue, or at least incomplete, in the loneliness. And it is the same turn tonight keeps making. Because loneliness is a feeling about distance, and distance, we have seen, faces two ways. The same vastness that separates us from any others also means that whatever is out there, whatever the universe contains, benevolent or indifferent or strange, is held away from us by that same immensity, so that our small world, our quiet corner, is not exposed and vulnerable in the great dark. It is protected by it, wrapped in light years of emptiness, the way a house in a vast night is wrapped in the dark that also keeps it private and safe. And there is a deeper answer to the loneliness, the deepest one, and it is this. You are not alone in the way that matters most tonight, because the universe, for all its size, is not somewhere else. You are not a small thing looking out at a vast cosmos that is separate from you and far away. You are made of it. The atoms in your body were forged in the stars we have been measuring, scattered by the deaths of suns, gathered across billions of years into the shape that is you, so that you are not an observer standing outside the universe feeling small against it. You are the universe, a piece of it, arranged into something that can look at the rest of itself and feel. And when you gaze up at the galaxies, it is not a lonely creature staring at a cold and distant everything. It is the cosmos through your eyes, coming briefly awake and looking at itself. And there is nothing lonely in that. There is something almost unbearably intimate in it. The universe and you, not two separated things across a vast gulf, but one thing, briefly, wonderfully. Knowing itself in the dark tonight as you rest, and that is the truest answer to the loneliness of the scale. That the vastness is not out there, away from you, holding you apart from everything. The vastness is what you are made of, and it is here, and it is home. Let us return one last time to the question that has no floor, the one about what lies beyond the horizon, because we have circled it all night. And I want to end our thinking about it with a kind of honesty that is rare and, I think, deeply restful. We genuinely do not know how big the universe is beyond what we can see. And here is the important part. We may never know, not because we are not clever enough, not because our instruments are too weak, but because the answer is hidden behind a wall that no cleverness and no instrument can ever pass. The horizon, the limit set by the speed of light and the age of the universe. A limit woven into the structure of reality itself. And no future technology, no matter how advanced, can see beyond it. Because the light from beyond it has not had time to arrive and never will. In the accelerating universe, for most of it, this is a strange kind of unknowable, different from the ordinary mysteries of science, which are puzzles we expect to solve eventually. Gaps in our knowledge that better experiments will fill. The size of the whole universe may be permanently, structurally unknowable. A question with a real answer that is sealed away from us forever by the laws of physics. And our species will very likely never know whether the universe is finite or infinite, whether it is 250 times our bubble or 10 to the power of a number we cannot write, or endless without any size at all. And we will pass that ignorance down through every future generation forever, because it cannot be resolved from inside, and there is no outside we can reach. And I want to suggest gently that this is not a tragedy, and not even a frustration, but something closer to a comfort, if you hold it the right way. And here is the way. There is a particular peace, a very old and very deep peace, in the presence of a mystery that you know cannot be solved, that no one is expected to solve, that will still be exactly as open and as vast 1,000 years from now as it is tonight. It asks nothing of you. You do not have to figure it out. You do not have to worry that someone else will figure it out and you will have missed it. You do not have to keep up or catch up or ever finish, because it does not finish. It is not the kind of thing that finishes. It is a permanent open window onto the infinite. And all you are ever asked to do with it is what you are doing right now, which is to wonder at it quietly from the warm, small center of your own small life, and then to rest. The size of the universe is the largest unanswered question there is, and it will still be unanswered tomorrow and next year and long after everyone alive tonight is gone, and their descendants and theirs all the way down will look up at the same sky and hold the same unanswerable question and feel the same quiet vertigo, and that continuity, that shared permanent wonder handed down across all the generations of a curious species. None of them ever solving it, all of them enriched by it, is not a failure of knowledge. It is one of the most beautiful inheritances we have, a mystery vast enough and deep enough to belong to everyone who will ever live and to never run out. And you are one of the ones who gets to hold it tonight in the dark, and you can hold it as lightly as you like, because it is not a problem to be solved before morning. It is a vastness to be rested in, and it will keep. So we arrive at the question underneath the question, the one that the numbers were always circling, which is not really how big is the universe, but what does its size mean for us, for you, lying there small and awake under all of it. And the reflexive answer, the one our culture hands us automatically, is that the size means we are nothing. A speck on a speck orbiting a spark, one of a septillion, lost in an endlessness that does not know we exist, and therefore insignificant, meaningless, small. And I want to take that feeling seriously, because it is honest, and because there is real medicine in it, a genuine relief. Whatever is weighing on you tonight, the argument you keep replaying, the worry that has been circling since this afternoon, the deadline, the regret, hold it up for a moment against 2 trillion galaxies and feel it lose some of its mass. Scale is a solvent for the small emergencies of a human day, and using the vastness this way, as a quiet place to set your burdens down for a while, is one of the oldest and healthiest things people do with the night sky. And it is a large part of why you might be listening right now, and there is nothing wrong with it. Smallness, honestly felt, is not despair. It is relief. But insignificance is the wrong conclusion, and I want to close by gently arguing against it, using only what we have actually seen tonight. Because the case for your significance is not sentimental, it is observational. Consider what this whole journey actually revealed. We toured a universe of a septillion stars, and everywhere we looked, we found magnificent, blazing, mindless matter. Suns burning by the trillion with no one to warm. Galaxies colliding in silent, slow motion with no one to see. Voids and walls and webs of unimaginable scale, and nowhere in all of it, in 93 billion light years of searching, have we yet found a single other place where the matter has woken up, where it has arranged itself into something that can look back at the rest and understand it. As far as our evidence currently reaches, and it reaches across the entire observable universe, the ability to know the universe exists in exactly one kind of place, behind eyes like yours, and it may be rare almost beyond imagining. And rarity is the very thing that makes small things precious, a truth every human being already knows. A diamond is a speck against a mountain and worth more than the mountain, because of what is arranged inside it. Nothing is valuable for being big. Things are valuable for being rare and ordered and irreplaceable. And by that measure, the true measure, the one we actually live by, the most valuable things in the known universe are not the giant burning stars or the vast walls of galaxies. They are the small, soft, improbable structures that can hold all of it in a thought. The minds, each one containing more connections than there are stars in our galaxy, each one able to do the single thing that all the vast dead grandeur cannot do, which is to care that any of it is there. And notice finally what the size of the universe turned out to be made of. At every scale, in both directions, emptiness. That was the finding, over and over. The solar system empty, the space between stars empty, the cosmic web empty, the atom empty. The universe is, by honest measure, a vast and patient nearly nothing. And in that near-perfect emptiness, structure is the miracle. Gathering is the rare exception. And there is no rarer, richer, more improbable gathering of structure known to exist anywhere than the one that is listening to these words. So the size does not make you nothing. The size is what it took to make you something. You are microscopic, yes, and the emptiness you are microscopic against is precisely what makes your existence the headline, not the footnote, of the whole vast cosmic story. And both of those truths are yours to keep tonight, and they do not cancel. They complete each other. Feel small whenever you need the relief of it. And then remember what the smallness is made of, and how rare it is, and how the universe had to be this unthinkably large, and this old, and this empty, to produce just here, just now, as far as anyone has ever found, a single small place where all of it, at last, became known. So let us gather the whole journey into our hands one last time, gently, and answer the question we began with, as honestly as one voice can in one night. How big is the universe, really? And the honest answer, we now know, comes in two parts, because the question splits, and both parts are true, and holding them together is the closest we can come to an answer. The universe we can see is 93 billion light years across. That is the observable universe, the bubble of everything whose light has had time to reach us, centered exactly on you, filled with 2 trillion galaxies and a septillion stars, arranged in a vast web of filaments and voids, walled at its every edge by the oldest light in existence, the faint glow of the moment the universe first turned clear, 13.8 billion years ago. That part has a number, and the number is beyond feeling, and it is only the part we can see. And then there is the universe, the whole thing, beyond our horizon, and that part, we found, has no comfortable answer at all, because the edge of our sight is not an edge of the cosmos. It is a horizon, a limit of seeing, and beyond it the universe continues, ordinary and shining, farther than we can ever look. At the very least 250 times wider than everything we can see, 15 million times greater in volume as the conservative floor, and quite possibly, if the flatness we measure means what it seems to mean, without any end at all, infinite, endless in every direction. So that everything we can see, the whole 93 billion light years, is not a small piece of the universe, but an infinitely small one, a single drop of an ocean that has no shore, and we cannot prove it. And we may never be able to, because we can never see past our own horizon. And so the truest answer to how big is the universe may simply be this: bigger than we can see, bigger than we can measure, possibly bigger than the word bigger can hold, possibly without size at all, because without end. And I promised you, at the very beginning, that this lack of an answer would turn out to be the most wonderful thing about the question. And here at the end is what I meant. A question with a simple answer is a door that closes. You learn the number, and you are done, and you move on. But how big is the universe is a door that keeps opening, room beyond room beyond room, the planets giving way to the galaxy to the 2 trillion, those to the endless whole, and perhaps that to stranger things still. And no matter how far you walk into it, there is always more, always another horizon, always a deeper room, and a mystery like that is not a weight that crushes you. It is a gift that keeps giving for your whole life, every clear night, forever. A question you can hold on any evening and never exhaust, and fall asleep inside, and wake up to still unsolved, still open, still waiting, patient and endless, and yours. If this journey gave you what you came for tonight, a few small things before you drift off. Subscribe, because this channel makes journeys like this one every week. Slow and calm and carefully made, built for exactly this hour, and there are more of them coming, some reaching farther out than tonight, and some going deeper into the small and the strange, and you should be aboard for all of them. Press like if the night treated you gently, because it genuinely helps these journeys find the next quiet mind lying awake somewhere, wondering how big it all is. And in the comments, along with your city and the time on your clock, tell me one thing: the moment tonight when the size stopped fitting in your head, the deep field hiding 3,000 galaxies in an empty speck, the wall of first light, the horizon that is not an edge, the possibility of no end at all, because I read every single comment slowly, and what stays with you decides where this channel drifts next. And now, the last thing, and the easiest, let all of it go. Set the numbers down, the 93 billion light years, the 2 trillion galaxies, the endless whole. Place every piece of it gently outside the door of this moment, because the deepest truth of the whole night was never the size at all. It was that somewhere in all that vastness, on one small world, in one small room, a single rare and precious gathering of mostly empty space arranged itself into